All right, hi everyone. Welcome to week 8. Today we're doing the last few sections of Unit 2, which is 2.10 through 2.13. We're working on cones and spheres today. Take a second to read this slide. Okay, so Pi Day is coming, and what we've learned in geometry especially, we've been learning a lot about pi, which is this crazy symbol right here, and it's in a lot of our formulas. And when we've been solving problems in class, what do we approximate pi to be, you guys? What do we approximate pi to be? 3.14. So there's actually what's called National Pi Day, and it's celebrated on 3/14. Get it? 3.14, celebrate on 3/14. 3/14 is a Saturday. So we're not going to have Pi Day on a Saturday, so instead we're going to be celebrating Pi Day here next Friday during our regular geometry time. I'm actually going to have the lab open for 2 hours, and it's 5 points of extra credit if you come by. So here's what's going to happen next Friday. We are going to be having all kinds of stations available around the room. So like the lab room will be divided into little stations that you will work through, and there'll be an activity at each station. You're going to be exploring what pi is, learning about pi, where that number comes from, how come it's 3.14. You'll be learning all those things. The lab will be open from 10 to 12, and the worksheet that I'm going to give you takes about 45 minutes. So if you come right at 10, you'd be done at 10:45. If you come at 10:30, you'd be done by 11:15. So do you need to be here the whole 2 hours? No, but it's just that the lab is open during that time frame. Does that make sense? Anybody at home have questions about that? So next Friday's session is not going to be a regular session. It's going to be a 5-point extra credit session, and it's not going to be broadcast like this because it's going to be stations to work through around the classroom. So I'll remind you of this next week, but Friday's going to be a special in-person only day for Friday. So I hope to see you here. And it's actually for all my classes. So geometry might be here, algebra 2 might be here, pre-calc might be here. It's just a fun Pi Day for everybody. Here's your week 8, oh, just kidding, week 8 essential question. And it says it will be given later in the session. So just stay tuned. It's going to be a kind of in-depth problem today. So if you're in person, you get to solve it in pairs and teams, which is great. If you're at home, you have to do it all by yourself. Okay, so example 1. If you're at home, can you give me a smiley face if you have the notes pre-printed out for me? I highly recommend that you do because then you don't have to redraw everything. Okay, so everybody go on your notes. Are we on this slide? Do we see it? I want you to label where's P and where's L. Label it on your drawing. Okay, where's P, where's L? So label it on your drawing. So P stands for perimeter of the base, and in our case it is a circle, you're right. So let's highlight that circle and call it a capital P. And then L stands for slant height. So last week we were talking how sometimes that can look like a 1. See how right here it sort of looks like a 1? So to keep it from looking like a 1, who remembers how we label it on my drawing instead? A cursive lowercase l. Good job. So your slant height is the one that is actually slanted. Let's label one other thing. What would we call this one coming straight down the middle that's forming this 90 degrees? That would be called the, Sabella? The altitude or the height, the regular height. Good job. So this would be called your H, or your altitude is fine. And then let's label one last thing. How about this piece of the puzzle? Good job. Radius, R, radius. Perfect. I believe some of the sections Austin might call this the axis of symmetry. So axis would be fine too. But for our sake of our formulas, we're always really looking for H because most of our formulas have H in them. So let me ask you this. How do we find these values in this picture? So we're going to practice. I'm going to give you some numbers here. I want us to take this little triangle and let's redraw it over here on the left-hand side. So let's all redraw our triangle right here. And I'm going to give you some numbers. So here we go. Fill in your numbers. Here's 10. Here's 3. I want to know L. How would I solve for L? And you need to have all these steps on your paper because this is going to happen in your notes. Good. So he said it really quietly, but it's Pythagorean Theorem. Anytime you have a 90-degree triangle, how do you find the third side? A squared plus b squared equals c squared. So let's all write that out. 10 squared plus 3 squared equals my slant height squared. So that would be 100 plus 9 equals L squared. Everybody okay? So far so good? So we get 109 equals L squared. I don't want to know L squared, I just want to know L, or just the slant height. So Destiny, do you remember how to get rid of a square? Can somebody help her? What do you think? Square root it. Square root it. So to get rid of a square, we square root. So the square root of 109 is 10.44. Yes, you are absolutely allowed to use a calculator, so it's not cheating. If you're at home, your computer has one under accessories, or obviously you could go online and look for a free calculator. Your phone also will do square roots too. So square root of 109 is 10.44. So my slant height is 10.44. In some of the problems I'm going to show you today, this is just one piece of the puzzle. So you have to be able to do this piece in order to solve the entire cone problem. So I wanted to make sure we're okay with the Pythagorean theorem. How about perimeter? How would I find perimeter? I'm going to change colors here. Maybe pick a green. Okay, so perimeter. If your perimeter is a circle, what's the distance around the circle? We wrote this down last week in our notes. What do we think? It was 2 pi r. Good job. 2 pi r is the perimeter of your circle. So in this example where I'm telling you that r was 3, right? My r was 3, my height was 10. How would I find the perimeter? I'd have to plug in 3. So I'd get pi equals 2 pi, or perimeter equals 2 pi r. But my r was a 3. So I would get 6 pi. Questions, comments, concerns? This is the basics that you need, like the base of the problem in order to be able to solve cone problems. So 2 pi r is distance around the circle. So I think we're ready to try a real problem now. I have 4 problems that we're going to do together, and then your essential question, which you can work on in pairs today. So we're going to do some simple ones together, and then you get sort of a harder one with your partner today. So here's example 2. We're going to find the surface area and volume for this cone. Okay, so step number 1, let's write down my surface area formula. So this is what I need to see for your essential question today. If I don't see it, you don't get full credit. And it will be the same for those of you that are here in person today. So you have to make sure you're understanding these steps to get your full credit. So big B. Big B means what? Area of the base. My base is a circle. What formula should I change big B into? What's the area of a circle? Pi. 2 pi r is the perimeter. We're going to get to that one in a minute. But big B is pi r squared. So area and perimeter do have different formulas. Remember how one of the weeks my essential question to you is where can you find all these formulas? Do you guys remember I asked you that in your book? Where can you find all these formulas in your book? And the answer was the very back has a formulary. It's like A16 through A18 has all the formulas for you. So if you're ever like, I forget that formula, look in the very back of your book and you guys have it. Let's keep filling in the rest of my formulas. So now P stands for perimeter of your base, which somebody just said is 2 pi r. So we're going to fill in P with 2 pi r. And L will stay L. So originally, see how they give you this really short formula with some letters in it? But those letters don't really help us until we replace the letter with the formula for that letter. So do you see how this little short formula got really expanded here? I have to see that in your notes for today. Right underneath it, we're going to fill it in with the numbers now. And then we shouldn't make any mistakes. We should be ready to go. So let's come straight down. So I have pi. I'm going to say r squared. So look at your picture. And everybody looking at their picture, everybody says r is 9, right? Radius is halfway across the circle. Let's keep going with my formula. I'm just writing the numbers directly underneath my formula. 1/2, 2 times pi times r. My r again is 9 times my L. Ooh, careful before you answer. Look at your picture. L is your slant height. Which of those numbers is the slant height? 15. 15 is the one that is slanted. Are we okay now that we pointed that out? So 15 was the one that was slanted. What would, well, we'll come back to 12 in a minute. We'll talk about 12. So I'm going to replace the L with a 15. Make sure the way that I've written it is not bugging you. What I mean by that is, up here, see I kind of have parentheses around those three things, but then down here I move my parentheses over here. It doesn't matter. Why doesn't it matter? Because they're all touching. What does it mean when everything's touching? Everything's going to get multiplied together. So please don't get bugged by me changing parentheses and moving them over here. Everything's just going to get multiplied together. So let's start here on the left. 9 squared means 9 times 9, so I'm going to get 81 pi. Good job. Now over here on the right, I can do them in any order I want. So I'm just going to go left to right. What's 1/2 of 2? What's half of 2? 1. That was easy. So 1 times 9, 9. 9 times 15. That one, 135. And I'm leaving the pi there. So that's me just multiplying all those numbers together. Half of 2 is 1. 1 times 9 is 9. 9 times 15, 135. We learned last week there's two ways I can write my final answer. The first way is I treat pi like a variable, meaning I'm going to treat it like an x, and I just add the numbers in front together. So my first answer can be written as 216 pi centimeters squared. I'm going to put a big or there. Or, what was the other way that I could write my answer? What would I have to do? What do you think, Sabella? Exactly. These two are still touching. That means they're multiplied. So I could really also multiply 216 times 3.14. So if you have a phone, if you have a calculator, can you try that please? Do 216 times pi times 3.14. And what would my other answer be? 678.24, fabulous answer, centimeters squared. These are the same answer. Everybody okay with that? Two formats, same answer. One has pi in it, one does not. How do you know which one you need for the test? Your test is multiple choice, so you're going to have to see. Do they have the decimal version or do they have the pi version? You have to be able to do both. So for the, we'll talk about the essential question later today, but anytime you guys are showing me your steps, what do I need to see? I need to see the formula. I need to see what does that letter really mean. I need to see you plugging the number in. I need to see your answer. So yes, right? Because there's no way you just say surface area 678.24. No. How'd you get that? Where did it come from? Like it doesn't mean anything without the formula, so I need to know how you got it. I'm going to switch pen colors and we're going to move on to the volume. So volume, let's start by rewriting my formula. Volume's always easier. Okay, so we always do volume second. Volume's always easier. Surface area is the hard one. So volume equals 1/3. Again, big B, that means nothing to me. We need to fill big B in with the formula. Big B is the area of my base. B for base, right? B for base. So my base is a circle. What's the area of a circle? Pi r squared. If you don't have these memorized, I would write them at the top of your notes. right? What's big B? What's capital P? You need both of those. Let's put them up here in the corner in case you need to add them to your very first page. These you need. So pi r squared and 2 pi r. You need these. You need these. These are for circles. So I would have those two formulas on the very front of these notes. That way you can find them for your tests and quizzes. Hopefully you'll have them memorized at some point, but I don't require that you have them memorized. I just need to know that you know how to use them. And then let's add in my h. Okay, so Anthony, I'm going to drop down the 1/3. I'm going to drop down the pi. What am I going to replace r with? 9. Fabulous. Adrian, what do I replace h with? 12. So let's talk about that. My first equation had an L. My second equation had an H. They're two different values, right? L means slant height. H means your regular height, the one that makes the 90. Does anybody have a question about where any of those numbers came from? So R and H. R and H. All right, let's simplify. So I get 1/3 pi times 91 times 12. And I can do these in any order I want. Oh, not 91, 81. There we go. I can do them in any order I want. Do we know that 1/3 is the same as just dividing by 3? Right? Same thing. So I'm going to do 81 times 12 using a calculator. And then I'm going to divide by 3. And I get 324 pi. Or, try it on your calculator. Can you multiply it out? What's your decimal version of your answer? It's big. 1017.36. Good job. Centimeters cubed. 2 answers. Same answer, different format. May you use calculators? Yes is the answer. Because until you pick the right values to plug in for all these letters, your calculator will not give you the right answer anyway. So I know that you pick the right numbers when you get the right answer. For the sake of earning points on your essential question, I want to see your work. But on a test or quiz, I obviously know that you picked the right numbers if you get the right answer. So we're going to try one that's just a teeny bit harder. Of course, they can't all be quite that easy, right? And you're thinking, oh, that one was an easy one? Okay, this one has one extra step to it. So this is example 3. This is our last cone problem, then we're going to move into spheres. So I'm going to start with surface area in pink. So surface area, big B plus 1/2 P times L. You guys take a second, whether you're in person or at home, underneath the big B and the big P, can you please write the appropriate equations in there, please? Look back in your notes if you have to. Don't leave it as a big B. Put the actual equation in there. Did we find them? I put them in a bubble on the last page for you. So see if yours matches mine. Pi r squared plus 1/2 2 pi r times L. Yay, nay? Yes? So pi stays pi. Look on your picture. R would be, where's R? 10 plus 1/2 2 pi times 10. Ooh, L. What's wrong with this problem? Not wrong with it, but what's my extra step? Doesn't give us L. It does not give us the slant height. That means I have to find it myself. Oh, we hate when that happens. But we know how to do the problem. It's just a couple extra steps. So I'm going to highlight L like in this blue color, and we're going to find L ourselves. They gave me the real height, They gave me the radius. They did not give me the slant height. So what I'm going to do is I'm going to move that triangle over here so that we can see it, except I cannot draw straight to save my life. So let me try again. Let's try that again. There's a line tool. I'm going to grab it. That's a little bit better. Okay, so there's my triangle. Let's add my numbers. We know that this one is 15. We know that this one is 10. I don't know my slant height. My very first example with you today was, how do I find the slant height if I don't give it to you? What formula do we have to use? Everybody says Pythagorean Theorem. Great. A squared plus b squared equals c squared. Are these problems long? Yes. How many homework problems have you guys been having each night? About 4. Between 4 and 7 problems. So we know that when you guys get long problems, you don't get that many assigned for homework. So we know they take time. So let's see, that would be 100 plus 225 equals L squared. So that's 325 equals L squared. And we said earlier, I don't want to know L squared, I want to know L. So to get rid of the square, we square root both sides. Calculators will do that for you very nicely. Type in square root of 325 and we get 18.03. We did all of that work just to find L. So let me highlight. This is my L. Where's it going to go in for L in my formula? You see how we had to do all that work just for one number. Let's plug it in. 18.03. From here, it's just multiplying things out. So on the right, we would get 100 pi plus 1/2 of 2 is 1. So 10 times 18 would be 180.3 pi. So 280.3 pi centimeters squared, or everyone grab their calculators. Can you multiply that out? What would be the decimal version, the non-pi version? So 280.3 times 3.14. So if you're on your computer at home, if you go to your start menu under accessories, there's a calculator, or you could pull up the internet and type in free calculator and one will pop up really fast. That's not what I got. I got 800, anybody with me? 879.29? 280. Yeah, 879.29. Okay. You okay? Are we on the same page? I'm going to change colors to like an orangey color, and we're going to try our volume now. Volume is always easier, so when we get to volume, we should be excited. Volume equals 1/3 big B times H. Oh, and here's a good thing too. Here's something to point out. If you're using the pi button on your calculator, does anybody have a calculator that has a pi symbol on it? If you're using like a scientific calculator, yours will have the pi symbol. The pi symbol is not rounded, meaning when we do 3.14, remember earlier I said that's an approximation? Pi keeps going. It's a weird number. We're going to learn about it next Friday on Pi Day. It's like a really cool number. If you use 3.14, your answer is going to be a little more rounded than if you use the actual pi button on your calculator. On a K-12 test, because some of you are saying, I got 880.5. That's if you use the real pi symbol. Your answers on a K-12 test, they'll never have 4 answers that are super duper close together. So your answer is going to be really obvious which one's the right one. So whether you use the pi button or 3.14, you're going to know which one's the right answer. They're not going to try and trick you on the test. Let's come over here to volume. Underneath big B, what is big B? Are we memorizing these? Hopefully sometime soon. Big B is pi r squared, area of the base, pi r squared. Let's fill in my numbers. So my r we said was 10, and this time it's h. So Brendan, where's my h in my picture? Brandon, which one's h? Yeah. Brayden, I'm sorry. Which one would be my H in my picture? Which number? That's okay. Can somebody help them? 15. Why 15? Because it makes the what? It's going straight down the middle. Yep. So your height's always the one that goes down the middle. The one that's making that 90 degree. 15. So again, since it's all multiplied, I can do them in any order I want. I'm going to do 1/3 of 15 because that's the same as 15 divided by 3. So I'm going to get 5. 5 times 10 squared, that's like saying 5 times 100. So I get 500 pi. Volume's always cubed. If you have a calculator, work out 500 times 3.14. What? Where did I lose you? So 1/3 of 15 is the same as 15 divided by 3, so I got 5. 5 times 10 squared, 5 times 100, 500. You can do them in any order you want. We'll all get the same answer because it's multiplied. That's the best thing. So 500 times pi, 500 times 3.14, we get, good job, Destiny, 1,570 centimeters cubed. All right, good job. Can you use paper and pen and work it out? Yeah, you could, but that's what we have a calculator for. Okay, so that's our last cone example. We're going to move into our next part of today, which is spheres. Spheres are easier. Yay, everybody excited? There's no triangles in a sphere. Yay! So there's no more Pythagorean Theorem. There's no more heights and slant heights. Spheres are just a ball, right? I played high school basketball, so a sphere is just a ball. If we're talking surface area, you're talking how much leather would cover the ball. If we're talking volume, how much air fills up the ball, right? The area inside is the volume. So let's try one. So 2 new formulas, but look, there's only one variable. Isn't that handy? There's only r in both problems. I like that. That's really nice. But here's the question. Look at your picture. Where's r? Okay. Where's r in your picture? Half of 10. Very good job. So what is 10? 10 is really the diameter, right, all the way across. So let's write up at the top. My r is 5. All right, add that up there. R is 5. So now let's try my formulas. They're very, very easy. Surface area equals 4 pi r squared. Right underneath the formula, can you add in your 5? Try it out. I should see work on your paper. Okay, you guys finish solving that and give me your 2 answers, please. Give it to me in pi format. Give it to me in decimal format. So 5 squared means 5 times 5. You're going to get 25. 25 times 4, 100 pi. Daniel C., how do I finish my units for surface area? What am I going to add to the end? Inches squared. Good job. And in decimal format, that would just be 314 inches squared. That's the or. Let's move into volume. Volume's easy too. 4/3 pi r cubed this time. So 4/3 pi and my r is a 5 cubed. So what we have to do is we have to work out 5 cubed and then times it by 4/3. How do you do that though without a calculator? I just want to walk you through the steps in case you've forgotten how fractions work. If here's my 4/3, 5 cubed is 5 times 5 times 5, which is 125. Are we okay with that? And that's the same as being over a 1. So you'd multiply across the top, across the bottom, and then you would divide. Does that make sense? In case you're doing it on paper, you'd do 4 times 125, 3 times 1, then you'd divide by that 3 on the bottom. This time it doesn't come out all nice and neat. You're going to have a decimal to begin with. We get 166.67 pi inches cubed. or we're going to get 523.33 inches cubed. Let's talk about fractions on a calculator. If you want to type in the fraction on the calculator, you can, but here's what you need to do. You have to use parentheses. So if I was going to type this in, I'm going to change colors and kind of point at it here. If I was going to type that in, I would have to do 4 divided by 3 times that 125. Do you guys see how that is how it would need to look on a calculator? Otherwise, the calculator doesn't know, oh, the 4/3 is the fraction. I have to do that times the 125. So just throwing that extra piece of info out there for you. Let's do volume. 4/3 pi r cubed. So 4/3 pi times 5 cubed. Oh, I just did that one. I'm just going crazy. This was volume. And nobody even stopped me. Just going crazy at the end of the day. Okay, Mr. Hayden stopped me. Okay. So here's your surface area. Here's your surface area. Here's your volume. I'm going to have you try one last one on your own. So I'm going to turn off the mic for a minute while I walk around and check the room. And you guys at home try it. When you're done with this problem at home, please type in your answer. So here's one more. Surface area volume. Your surface area is kind of big because the number I gave you is a 14. So I'm going to give you a minute to work on this one. So try this one yourself, and then I will be right back on the mic. Okay, so just check your steps, and if you don't have a calculator, as long as you have the right numbers in there, you know at least you know how to set it up correctly. So it just would have been that 14 squared. So by the time I do 14 squared times 4, you would get 784 pi centimeters squared. Or if you multiplied it out, you get 2,461.76. For volume, it's the 4/3 pi r cubed. 4/3 pi. My r again is 14 cubed. So when I do 4/3 times 14 cubed, I would get 3658.67 pi centimeters cubed. Or when you multiply it out, 11,488.21. The key that I really wanted you guys to practice today was just setting up your formulas, because setting up your formula correctly is half the battle. Once you have your formula set up, it's just kind of plug and chug with a calculator. So today we're going to be practicing with a partner if you are here in person. If you're at home, you'll be working on this problem on your own. So if you guys look, I gave you a picture on your very last slide. Can you guys all flip to your last page of your notes? So everybody flip to the last page of your notes. All right, so let's look at my very last picture. I know that I didn't give you any of these questions on there. That's what we're going to add right now, but you do not have to write all this that's in black. We're just going to read it together. The picture describes what it says in black. So let's read it. A cylinder holds 3 tennis balls. Have you guys ever purchased a container of tennis balls? I used to play tennis in high school too, right? It comes in this cylinder container. There's 3 balls in there. So that's kind of what we're talking about here. The diameter of the container is 4 inches. Diameter is all the way across, right? And its height is 8.5 inches. The diameter of each ball is 3 inches. What is the unused volume of the container when it's holding all 3 balls? So I'm going to give you a big boost and help you out with the majority of the formula, and then you'll work on it with a partner. Here are the 3 questions that you're answering for week 8, technically. You do have to show all of your steps, but let's talk about what is this question really asking you to do. It says, what is the unused volume? So we're talking volume here. So here's what we're going to do. We need to find the volume of the cylinder And then what do I have to do to that? After I find the volume of the whole thing, I want to know the unused volume. What do you think is going to be happening there? And if you're at home, you can type it in too. I'm going to be subtracting, but what am I subtracting exactly? The volume of the, we're close. The volume of the spheres, the volume of the balls. So let's write that down. I'm going to do the volume of the whole cylinder, and I'm going to subtract out the volume of the balls. But let's be a little more specific. It's going to be the volume of how many? 3 balls. Okay? So I'm going to change that slightly. You're going to do the volume of the cylinder minus the volume of 3 balls. That would be your final answer. Okay? I'm going to work on it in pairs today if you're here. I would love for those of you watching online to be here if at all possible in the future. This is a homework question, by the way. It's one of the challenge problems in the homework, but it's absolutely doable. So what are you going to do to turn in for me? Part A, I want to know what 2 formulas do you need. So you're going to type out what's the formula for the volume of the cylinder, what's the formula for the volume of a ball. What shape is a ball, you guys? So over here we're talking spheres. Didn't we do spheres today? We did. So what 2 formulas do I need? You need to give me, don't just say for A, volume cylinder, volume of a sphere. You can't use those words. I want to see the formula itself. What times what times what? For B, you're going to show me the formula with all of your numbers plugged in like we practiced all day, and C, you will give me your final answer. So go ahead, if you're at home, you can log off and work on this and put it in the box for week 8. So thanks, guys. Have an awesome week, and I hope to see you back here for Pi Day next Friday. Hey, that kind of rhymes. Okay. Yes, I'm a math nerd. I know. All right, have a great day. Have a nice weekend.